If you had quiz B, then here are the correct answers. For the first problem, hopefully you recognize that the value of a is -1. The a value is the coefficient of the x squared. In this case, it's a -1, making it a parabola that opens up downward and making it a maximum. The b value is -4, which we'll use for the axis of symmetry. Negative b, in this case, -4 is a +4, divided by 2 times a. Our a value is -1, so 2 times -1 is -2, and 4 divided by -2 is -2. So the axis of symmetry is -2, and it's also our x-coordinate for our vertex. How do we find the y-coordinate? We plug that -2 back into the original equation. And it's important to make sure that we're doing the -2 times -2 first, which is a +4. And then that negative sign out front is the opposite of that, or -1 times the 4, which is -4, minus 4 times -2, which turns into plus 4 times 2, which is 8, and then minus 4. So 4 plus 8, -4 plus 8 is 4, and 4 minus 4 is 0. So -2, 0 is our vertex for number 1. Then to find the y-intercept, we're going to plug in the number 0 for x. And what that does is it makes everything times 0, 0, leaving us with our c value, which is -4. So 0, -4 is our y-intercept. So I can plot that right here, and then I can reflect it over our axis of symmetry to give us another point here. So we're going to connect those with arrows here and curves, putting the arrows at the end, noting that it's a parabola that continues on forever. And if we laid that parabola flat against the x-axis, we would find that our domain is all real numbers. But if we folded it in half on the y-axis, we would find that it would be all real numbers less than our vertex there. So we're going to say less than or equal to 0 for our range values. For question number 2, we have a quadratic equation here that can be factored. The only way we can get a positive c value and a negative b value is to have both of these factors and the binomials be negative. So in this case, -3 and -2 will give us a +6 when we multiply it, and it will give us a -5 when we add them together. So when we have x minus 3 equals 0 and x minus 2 equals 0, we get that our solutions, or our roots, are equal to 3 and 2. How does that translate down here on the graph? Well, over 2 and over 3, those two will be our roots, or the numbers that make our equation true when y is equal to 0. So this parabola is going to be a minimum because the coefficient 1 is a positive number, so it will open up like this. The axis of symmetry is -b over 2a, and so in this case, -b would be the negative or opposite of -5, which is 5, over 2 times a. 2 times 1 is 2. So some of you got a little confused by that because it wasn't a nice, neat integer. 5/2 is 2.5. So if I go over here to 2.5, my axis of symmetry is going to be at 2.5. It's also going to be my x-coordinate for my vertex. How do we find the y-coordinate? Well, we have to plug in 2.5 back into the original equation up here. So 2.5 times 2.5 is 6.25 minus 5 times 2.5. So that is minus 12.5 and then plus 6. So in the end, we have 6.25 plus 6, which is 12.25, and 12.25 minus 12.5 is negative 0.25. So negative 0.25 is my y-coordinate of the vertex. So if I plot that point, it's just going to be right here below the x-axis. The y-intercept can be found by plugging in 0 for x. And when you plug in 0 for x, we find out that the c value ends up being our y-intercept. So when we take 0 squared minus 5 times 0, we're left with 6 for our y-intercept. So when I plot 0, 6, 1, 2, 3, 4, 5, 6, I can then reflect that over the axis of symmetry and then draw my parabola here. If I laid that parabola flat on the x-axis, we would find that the domain is all real numbers, and then the range, if we folded that in half on the y-axis, it would be all real numbers greater than or equal to that y value of negative 0.25. Finally, question number 3, we are looking at the parent function of x squared. So the general function that looks like this, touching down at the point 0, 0, how do these other functions compare to that when we start adding and subtracting and adding coefficients? So in this case, the width would be the same as our parent function, but it's going to shift 6 units to the right, and it's not going to shift at all on the y-axis, and it's going to be a minimum just like our parent function. For the second one, we have a negative a value, which means it's going to be a maximum, and it's a fraction between 0 and 1, so it's going to be a little bit wider than our parent function. The plus 3 right here tells me that it's going to shift 3 units to the left on the x-axis, and this constant negative 1 means it's going to shift down on the y-axis.